Welcome to Physics Lab students. Today we are going to conduct one simple experiment. Aim of the experiment is to find the force constant of a helical spring by plotting a graph between the load and the extension. So, the apparatus needed for this is the spring, a rigid support, slotted weights and a scale, fine pointer and a hook. Now, what is the theory behind it? So, theory behind it, when a load F suspended from a lower free end of a spring hanging from a rigid support increases its length by amount L, then the force is directly proportional to the length. So, F is proportional to the length, or we can able to say F is equal to K into L, where K is constant of proportionality. Now, this is the spring. This spring, the helical spring, is anchored to the rigid support, and here is the scale, and we have the sorted the weights. So, each one is of 50 grams. Now, the spring is the hand and here is the pointer. So, let us read this particular value. The pointer is at 13.5 centimeter. Now, increase the weight here. So, this hanger weight is 50 grams including this hanger. So, just hang it. Now, the length is increases to what here? The 14.5. Now, take another weight, the 50 grams, then hang this one to here. Increase the 50 grams. Now, this pointer is reached 16.5. Likewise, they go on increasing. Okay. The next is increase further 50 grams. It is equal to the 19.5. Now, increase the further. Then it is equal to the 22.5. Okay. Next, increase further. Can take another weight. It is almost equal to 25.5. So, 100, 200, 250 over. Let us try another one. Okay. Let's take 50 grams again and keep. It is almost equal to 29.5. Now, the load is increases. As the force is goes on increases, the length is also increases. F is directly proportional to L. Now, you go on decrease this the weight. So, just decrease this one. Okay. Remove the weight from here. The first one is 29.5. Next, decrease it to what here 25.5. Once again, decrease 50. So, what you will get is 22.5, and further you decrease. So you will get almost the 19.5, and then once again you decrease the load. So it is almost 16.5, and the loss 2 is, so here we will get, once again you decrease, it is 14.5, and then if you remove this entire angle, so then it is comes to what here, 13.5. Note down all these values in a tabular column. Let us note down this tabular column. On tabulating, the first one is the serial number. The load in the handle, you already know that 0, 50, 100, 150, 150, 200, 250 and 300. When the load is increases, it is equal to first value is 13.5, 14.5, 16.5, 19.5, 22.5, 25.5 and the last one is 28.5. While the decreasing this one, so what we get is so 28.5, and further it is 25.5, 22.5 and likewise 19.5, 16.5, 14.5 and 13.5. So these are the values we got. And take the mean value of this. So the mean value is equal to Z is equal to X plus Y. So the load increasing is called X, load decreasing is called Y. X plus Y divided by 2. So the same values you will get. So that is 13.5, 14.5, 16.5, 19.5, 22.5, 25.5 and 28.5. Now, what is an extension? How to find out extension? 13.5, the first value please see, 13.5 minus of 13.5 is equal to what? The 0. Then the 14.5 minus of what? 13.5 is equal to what? 1. So add 1 here. Okay. Next further, so here 16.5 minus of 13.2. So how much we get? So we get almost equal to what? 3. Okay. Next one is, so 19.5 to 13.6, you will get what? 6. Okay, so here we will get 6, value is 6. In the same manner, 22.5 and 13.5, you will get what? 9. Okay, 25.5 minus of 30.5, we will get nearly 12. Okay. Next value is 28.5 minus of 13.5, we will get 15. Okay. So this is then extending or extension value. Now the draw graph between what and what? The load and also extension. So please see the graph. We have drawn the load and extension graph. So here is the load. Load is nothing but a force. The force against what? The extension. So this is the one, the sample graph is given, but actual graph is like this. So just I will show you the actual graph is drawn. Okay. So here is an actual graph. So this is an x-axis. We have considered the force in what? Gram weight. And here is an y-axis. We had considered the extension, that is in centimeter. So what the scale is considered here is, x-axis is 1 centimeter is equal to the 50 gram weight force. Y-axis is equal to 1 centimeter itself. So therefore, if you draw the graph, you will get a straight line graph like this. So for 50, it is equal to what? The 1. And for 100, it is 3. And for 150, it is for 6. And for 200, it is 9. And 250, you got 12. And 300, we got 50. So take a one slope, call this as what? A, B, C. And what is the K value? The K is the constant, that is the force per unit length. The force is, so we have from B to C, so that is BC divided by AC is the extension, that is AC. BC divided by AC. So the BC is equal to 200 and AC is equal to the 12. So it is almost equal to 16.66 gram weight per centimeter. So this is the spring constant what we are using. So this is how we can able to find the spring constant. Thank you for watching the video. Thank you very much.